All right. In this video, we're going to show how the central limit theorem is used in conjunction with t-statistics to obtain p-values. And later we'll see how they're used to construct confidence intervals as well. So we're going to use the mouse example where we constructed a difference in mean already. What we're going to do now is construct the t-statistics. For that, we need to estimate the standard error, and we do that by taking the square root of the variance of the sample estimate of the variance, oops, not variance, just var, divided by n, where n is the sample size, that's up here, and then we add variance of the control, and that gives us standard error estimate, and we can form a t-statistic by simply dividing the observed difference by its estimated standard deviation. Okay, there we go. Now, what's really useful about the central limit theorem is that if we're willing to assume that it, in fact, it is a good approximation, that the normal approximation holds for the null distribution, then we don't need to have access to the population data. So in a realistic situation where we don't have access to that data, we can actually compute a p-value. So the t-statistic central limit theorem is telling us the null distribution is approximated by a normal distribution with mean 0 and variance 1. So that means that we can compute p-values by simply computing that. So the function p-norm tells us how what proportion of normally distributed data with mean 0 and standard deviation 1 are lower than whatever value you put here. So the p-value would be given to us by that. Now that's only bigger, so if we want to test bigger or bigger in absolute value, then we multiply that by 2 because we need the two tails, and we have ourselves an estimate of a p-value. Okay, so now notice that we did not use the population data at all. We simply use the sample data at hand. So now the question that we can ask ourselves is how good of an approximation this is, and here is where we can use the population data to test that. So we can again act as if we don't have as if we have access to that data, and we redo this. Let's put n here now. We redo this, but now we divide the nulls by the standard error estimate. Let's put that here, and that will give us the actual null distribution of that t-statistic, which we're assuming using central limit theorem that it is in fact normally distributed. So we run that. We have to read in the data first, and then we run the code, and now we can see how good this this distribution is. We'll load the Rafalev package to make some pictures. So if we make a plot, a QQ plot against the normal for these nulls, it should be right on a line. It should have slope 1 and mean and intercept 0. So we can check that by, well, instead of QQ line, we just should do AB line 0, 1. That means make a line with intercept 0 and slope 1, and it should go right through the data, and it's pretty close, telling us that the central limit theorem here is in fact giving us a pretty good approximation. So the p-value we obtained is a good approximation of the actual p-value. So now to see when the t-statistics breaks down very quickly, let's change n to 3 here. So let's see what this looks like if I do a simulation now, but I'm sampling 3 values instead of 12. We're going to see what happens to the null. We redo the QQ norm plots, and we can see that now the data does not follow a normal. Oh, sorry, that's not quite right. We have to change this to 3 as well. So let's redo it. It's not quite that bad. and now we make the we make these pictures, and we can see it's still not very good. There's tails that are values that are much bigger than what are predicted by the normal. So in the case of of a sample size of 3, the normal approximation is not good at all with this particular data set. And it is in this case that we would instead use the t approximation. Like if, as we explained earlier, if we believe the original data follows a normal distribution, then in fact the t approximation should work. Okay, so there's your simulation showing why it is that we need bigger sample sizes, and in the next video we'll show how we actually run the t-test in practice.